Okay, I want to go ahead and cover a few of these problems on this integrate by making substitutions, kind of the day 2 worksheet. I'm not going to do every problem. I'll show you all the answers at the end. You can check. Ones I've been having questions about because there may be a little bit different form. Looking at this number 2, I helped several people with number 2. Don't treat it any differently than if it was a 2x or a 4x. When you have the radical x, that's just your angle. You usually want to let that be your u value. So write it as x to the 1/2. Find du. And then solve for dx. Now, a couple things that will help you with your fractions when you solve for dx. You're multiplying both sides by 2 and x to the positive 1/2. Because if you divide by negative 1/2 over here, it's going to move up. So you really end up with 2x to the 1/2 du when you switch. So that gets rid of that. Now I can go back and substitute. I have 1 over x to the 1/2. That's my right here. And sine of u. And then dx, 2x to the 1/2. X to the 1/2 cancel out. I'm just doing the integral of the 2 sine u du portion. We're at the du. And then from there you can integrate just like any other problem. Negative cosine. You're going to find that some of the trig ones have a little bit of a twist to them. There's some strategies that will help you figure out what you're doing. Let's go to number 4. And number 4 is a power. So if you think about a chain rule problem, this started as a chain rule problem. The chain rule is the derivative of the outside times the derivative of the inside. So usually the power was the outside. That means this was the inside. So if we did another power one, like on that one, most of you had no trouble picking the inside to be x squared plus 1. So remember that this is really the integral of cosine x to the 3rd times sine x. It's just a little change of form that helps you think about that. So there is my u. And then the du be negative sine x dx. And then we substitute. So this is u to the 3rd sine x. And then my dx goes here, du over negative sine x. So it's just negative u to the 3rd. And again, pretty easy to integrate from there. Remember, you can always take the derivative to get your answer back. All right. Number 5 also looks like that, a power. So when you go to set this up, if you're like, yeah, I just listened to your suggestion, Mr. Kirkton, so I'm going to be super diligent like I always do and listen to everything that you say and apply it. So you go, okay, I'm going to let u be the cosecant. So that du is negative cosecant cotangent. And then I solve for dx. Negative cosecant cotangent. I listen to you, Mr. Kirkton. You usually tell me the truth about math. So I'm going to go plug it back in. Cotangent doesn't change. So cosecant, that was u, so it's u squared. And then dx is du over negative cosecant x cotangent x. And the cotangent cancel. And we're left with some x's and a u. And so you might get yourself a little bit confused there. You might find yourself on the confusion train. Now, One thing you can do is look for a second substitution. We haven't talked about that yet. If we want this to be a u, we could make this negative u. So I really have u squared du over, well, that's already negative cosecant, so negative u. Starts to get a little bit crazy in there. And then we're like, okay, did I do it right? Did I substitute wrong? So if you get to this point and you don't know double substitution yet, just switch what your u value was. And to give you a hint, if you let u be if you know one of them is the derivative of the other, like you know that cosecant squared is the derivative of cotangent, negative cosecant squared. So let the cotangent be your u value, because then when you take the derivative, you're going to get the same function there. So that's kind of something to look for. If you know you're going to do that, that way this will cancel out when we go to substitute back in. Now we can write integral of u times cosecant squared times du over negative cosecant squared. Cancel, cancel. So I have a negative 4, or sorry, negative u, that's a u, du. Integral negative u is negative 1/2 u squared plus c. My u was cotangent, plug it back in. If we would have done our double substitution over here, the mistaken one, this would have been negative u du. The integral of that would be negative 1/2 u squared plus c, and u would have been cosecant. Very interesting. So that way it works too. I wouldn't have taken that route. So general rules, looking for powers, that'll be your use. Fairly easy on the polynomials. The trig ones get a little bit sneaky. Here's the answers for the first side, and I'll do the second side in the second video. If you make a mistake, sometimes you forget to integrate when you're in the business of trying to change everything around. You just forget to integrate. So that'll be the end of this first one. Thanks for playing.